Hello everyone, welcome back. My name is Joe and I will be one of your free hosts today. This is Enso. We are a dual representation programming language for all kinds of applications, but particularly data and data processing. And this is the season finale of our little Twitch show that we've had going on. What does that mean? It means we've been streaming for a couple of weeks now. This is week number 6, I believe. And after this, we're going to take a little bit of a break, line up some new content for you, and then we'll be back in the future. But for now, we have one last show for you all, which I'm super excited about. We have Marcin again. Marcin's been with us for all the shows, live coding away, but also going to have our CEO Wojciech, and we're going to be chatting about the future of Enso and the vision of Enso. Because we've spoken a lot about the here and now, what Enso is like now, what we're working on, and it'll be good to look ahead a little bit because Enso is still rapidly in development, and we want to make sure that you know and can be excited for all of the things to come. So in a moment, I'll add up Marcin and Wojciech, and we'll kick off. But before that, a couple of notes for you all. As I said, this is going to be the last show for a little while. Not too long though. We're going to take a couple of weeks off and then we'll be back. If you want to keep up to date with when the show goes live again, there's a couple of places you should keep an eye on. First of all, you can follow us here on Twitch. Hit the follow button, and then if you want notifications, you can hit that bell to get my YouTube street cred in. You can do that at twitch.tv enso_org. We also obviously are on Twitter, where we tweet about all the shows and what's coming up, and also our releases. You can find that at twitter.com/enso_org. As well as that, we obviously have our Discord community where you can ask questions, chat with the community. You can ask us questions when we're not on air. Funny thing. We are available all the time, and we do office hours on Wednesdays, so you can chat to the team anytime at discord.gg/Enso. And finally, if you want to keep up with the development of Enso and get the newest releases as soon as they happen, you can do that at github.com/enso-org/Enso. So that is all the places and all of the things. Hi Hugh, hi Marcin, hi Wojciech. Thanks for joining me in chat before you join me on screen. Let's get you on screen and let's kick things off. There's Marcin, there's Wojciech. Hey folks, how you doing?
Hi guys.
Hello.
Great to see you.
Awesome.
Doing great.
Thanks.
How are you doing, Joe?
Oh, I'm doing wonderful. I'm full of energy. So Marcin, we've seen you a million times before. We don't need an introduction from you. Wojciech, would you like to introduce yourself?
Yeah, I'm Wojciech Danilo. Nice to see you guys. Nice to see you, Joe. Nice to see you, Marcin. Actually, during these COVID times, we don't see each other in person really often. But actually, I have seen Marcin today in person. So yeah, I'm one of the founders of the company, next to Marcin, who is the original founder. And we've been working on making this vision reality. From the technical point of view, Marcin is responsible for the compiler development, while I'm responsible for the graphical interface development, the vision behind Enso, and how it looks and feels. So yeah, I would love to share this with you and answer any questions that would appear here.
Yeah, and I was being mean, Marcin. Please introduce yourself.
Right, so my name is Marcin. I used to be a founder, but now I'm working in a strictly technical capacity, having lots of fun with writing the compiler, being one of the people responsible for it. I don't like saying that I'm responsible for the compiler. It's a lot of people behind the scenes actually being responsible for it. And I'm but one of them.
Indeed. So a couple of things to run through before we kick off. This, being our season finale and having Wojciech here with us is an opportunity. I heard it now. Thanks, Zara. Is an opportunity for you to ask questions of the team. I can see we've got Oscar joining us on YouTube, who's been watching the project for a while. Thank you for joining us on Twitch. This is your opportunity to ask questions. Anything Enso, where we're going, where we've been, what's changed, anything like that. Feel free to drop those questions in chat. I know that I'm watching. I've got Twitch over there and YouTube over here, and I know that Wojciech and Marcin and Ara is watching as well. So please ask your questions because we've got 2 hours with y'all, and so please take advantage of this time.
That is amazing. One more thing actually is, of course, when I mentioned that Marcin is working on the compiler, Ara on our chat is the leader of our compiler team. Hi Ara, great to see you here.
Yeah, our live streams are a team occasion. Everyone likes to come into the chat to troll us while we're live. So with that in mind, I believe actually where we're going to start with Wojciech is, I guess, where the product is now, because I believe we have a release going out imminently. Would you like to tell us a little bit about what people can expect from this new release and what's happening?
Yeah, so we've been working really hard on the newest release, and actually I'm really happy that we went to this point that we are right now in, because when we released Luna, so we changed the name from Luna to Enso, and when I'm referring to Luna, I mean the old release, and to Enso the new release. So when we released Luna 1.0 back then, so like 1.5 years or 2 years ago, we wanted to check if really what we are trying to show people is making sense for them. So we have released that. It was not working really fast. The interface was sluggish. The compiler and the data crunching engine was a little bit slow. But actually, it allows us to grab amazing connection with different people, with different companies, and actually check if what we are providing to them, if our promise can actually become a value. So value both for data scientists as well as for businesses. And as soon as we have discovered that actually, yeah, what we are trying to do makes actually sense, also from the big business perspective, we told ourselves, okay, let's start working on a real production version of that. So we started working on Enso 2.0. And there are 3 big changes in that. The first one is that we have a brand new data crunching engine. And this is what, for example, Ara, Marcin, Dmitry was working on. And I'm so grateful to see it, because actually this is right now amazing. Actually, our new data crunching engine is so fast that in some benchmarks, for example, against Python, we are over 100 times faster than Python code. And this engine is incredible, because it's not only fast, but it can also use libraries from different languages like Java, JavaScript, or Python. That's incredible. The another thing that we did is the new graphical interface that is right now WebGL based. It is super fast. Even with huge scenes, you've got 60 frames per second on laptop, and it also allowed us for the third thing, which is crazy data visualizations. So because, I mentioned that earlier, Joe, I think to you, that because, for example, of this new interface and the new engine to display things, we were able to create also visualizations based on WebGL that are able to run, like, display 1 million of points, 60 frames per second, which is completely not something that you cannot see in other products. So we made pretty big changes, and I'm so happy that we went to a point where we have the alpha of this new technology released. So that's super cool.
Sorry, my mouse was in the wrong place. I couldn't unmute fast enough. Awesome. Thank you so much. So we've already got questions coming in. Thank you so much for those in chat, folks. So I'm going to dive straight into those and save my questions for later. So we've got a really good question that you answered in Discord recently, which I do want to get into, because Hugh, who's also in chat, asked about this the other day. But we'll start off with Dizanex. What is the biggest already created application using Enso, even if it's just an example app?
Okay, so that's a good question. So I will answer that in 2 parts. The first part is that we have pretty big standard library. So in our standard library, there are a lot of files, a lot of utilities for everything, like for processes, for time utilities, for HTTP, for geographical maps, for visualization, and all these libraries are working together in the graph. So this is pretty big code base. Regarding data processing, when we are working with, for example, banks or with IoT companies or pharma industries, these are companies that normally ask us for collaboration in some domains. Then the workflows that they build are normally contain of like up to 100 nodes. However, these nodes are hierarchical. They are using also our standard library. So in fact, if you double click on a node, you can go inside and see what's deeper. So in fact, you can assume that there are like hundreds of thousands or thousands of nodes there. Did I answer your question?
I think so. But while we're talking about the standard library and it itself being a great example of stuff built in Enso, Marcin, do you want to chip in on this? Because there's some really neat things that are built in the standard library. Like today, I was writing the docs for operators and got to the section about mixed fix operators and the fact that if then is actually defined as a particular type of operator in the standard library. Do you want to talk a little bit about some of, I guess, the not unexpected, but like this, I feel like there's some things in the Enso standard library that would often be seen implemented at like the parser or the language level that have been done in a really interesting way in Enso.
Well, yeah. So the largest workhorse of the whole standard library is our beautiful Java interop, which is great, right? Because this greatly reduces the number of things that we have to build into the language that have to be compiled together with the language, and instead we are using the same mechanisms that any user would use if they actually wanted to build their own library, right? So for example, things like text processing, which is normally something that is built very deeply into the language itself. In the case of Enso, most text operations are just imported straight from the Java standard library without any actual backend support for things like, I don't know, reversing a string or other such low-level operations, right? So if you go to the sources of our standard library, you can see all of that, and you can actually kind of see some design patterns that we use when operating, when interoperating with Java. So, for example, the way we handle our strings library, you can see how to like consume a mutable iterator from Java and expose it into Enso such that it looks nice from the Enso side.
Awesome, thank you. Okay, Disnex, I've seen your question, but we'll do Oscar's first because Oscar asked a while ago. Wojciech, as I said, this is a question that you answered recently in our Discord. Go ahead. Yeah. Oh,
so sorry, do you hear me well? Because actually I see that. Yeah, do you hear me well?
You're good right now, yeah. Is your connection breaking up?
Okay, because actually, yeah, I see that when I'm streaming, then actually my MacBook goes a little bit crazy with processes under the hood, so I'm not sure. In case you will see some delay on my side, just tell me, and I will try to rebuild only with this Chrome tab open, so just tell me about that.
No problem. Yeah, we'll let you know. And again, same with you viewers. If we start breaking up, sometimes it can be difficult for us to know. If we disappear, let us know in chat and we will fix it. So Oscar asked a question that you answered recently in our Discord, Wojciech, which is how are you guys planning on managing streaming data? Like if I'm to write something that completely avoids malloc because the data sent is, and I quote, good gigabytes. Do you want to talk a little bit about your vision behind streaming data for Enso? Oh,
yeah. So let me do this thing that Marcin, if you could. So Marcin, if you could start answering that, I would rebuild and we'll be back with you guys in a minute. Something is going crazy with my computer. Okay,
right.
So I will be just.
Yeah, sure. Let's get the techie stuff out of the way. Right. So for streaming, there's two answers to the question. Like for many questions in an early product, how do we do it right now? The answer is we don't, not in the IDE. So all of our libraries are currently sort of assuming that we are able to load all of the data into memory and start from there. Now, if you would like to use, for example, if you would like to connect to Spark, you could do that from the CLI. So just from the textual distribution of Enso, which also means that you could, for example, prototype your pipeline using the IDE and then deploy that prototype onto your huge like Spark cluster or whatever you have. Although we don't have connectors built in for that, but as I said before, there is great Java interop, so we can just use that. So this is the state of the world right now. Regarding how do we do that in the IDE, we are actually planning to in the next few months start fleshing all of this out to be able to connect a streaming source into the IDE such that you can, for example, see previews of your data. So this would be okay. The answer has three parts now because I just off-topped myself. So right, so if you have a live feed of data, right? Like let's say you connect to the Twitter API and you connect to the fire hose of data from Twitter. That is how you would do that in the future. You will just connect and you will see that streaming source displayed in the IDE, which will be great when it arrives. This is not currently possible. However, I just realized that there is one more thing that you said about streaming data and not necessarily loading all of the data in memory. So that is not strictly true, actually. So if you are thinking about frameworks that are able to do, like for example, MapReduce, you could connect to Spark from the IDE currently. There is nothing stopping you. You won't get a live feed, but again, in Spark, I think the biggest boon is that you can run a computation across the whole cluster. So you could conceivably start doing that. Just to give you an example, we are currently working on a connector to SQL databases. So you will be able to like work with Postgres. So this would be an example of how to work with data without loading all of it into the memory. You will just be able to build an AST of a SQL query in Enso and then run that query on your database without actually loading all the data to Enso, right?
Very cool. Thank you for that, Marcin.
Hi guys, I'm back.
Hey.
You sound good. Perfect.
Super cool. Sorry for that.
Go ahead. Yeah. So Marcin, run us through the current state of data streaming on Enso and different ways it could work with using our interop to talk to Spark on the CLI, or as you just mentioned, still being able to use the IDE and like loading in limited view like chunks of that data via the IDE. But if you have anything you want to add, now is your time. Else I'll move on to the next question.
There is one interesting question about, does Enso implement flow-based programming paradigm? Did you answer that or not?
No, that's all you. Go ahead.
Okay, that's super cool. So yeah, that's very good question. That's very interesting. So actually, Enso implements flow-based programming, but it's not only flow-based programming. So the thing here is that when you are connecting nodes in Enso, you can define even in our vision. So actually, this is not yet exposed to the users, but you can define per library or per node what actually connection between nodes means. So for example, you can define that a connection is actually a stream of data, a queue of data, and that, for example, nodes can wait for the incoming data. But by default, when you download Enso right now, our default mode is that connection between nodes means that when the data is computed, the data is just used by the next node. By used, I mean there is no queue, there is no performance overhead over this passing data. You can think about connection between nodes like about value assigning in textual programming languages. So in fact, our textual code shows that. So if you've got A equals foo bar bus and B equals foo from A, then actually there would be a connection based on this A variable.
Oh, you muted, Wojciech. I guess there's a shortcut somewhere.
Okay, amazing. So yeah, and one more thing about that. So in our textual language, we also have this equal signs, and basically these equal signs mean that hey, this function on the right is evaluated. It is then pattern matched on the left side. However, again, this is the vision that we are not exposing yet to the users, is that you would be able to redefine what actually equal sign means. And if you are familiar with, for example, Haskell or Idris or Agda or some functional programming languages like that, then you may be familiar with the monad concept. And this is exactly what allows us to redefine what equals means, what allows us to redefine what connection means between nodes. And in such way, we can actually redefine that the connection between nodes is a queue, and nodes are waiting for the evaluation, and we can, for example, implement a full flow-based programming this way. We can also implement that based on libraries. So instead of using monads, we can just create a structure that we are sending the structure between nodes, and the structure inside implements streaming. So I believe that Marcin was talking about that when I was away. I didn't hear that, but I believe he was mentioning that. So yeah, we can. So Enso is more generic than flow-based programming, and flow-based programming is a subset of what you can do here.
Awesome, thank you. Marcin, even though you answered in the comments, I'm going to make you repeat it verbally for the recording. So Divinex asked, how about testing frameworks? Are there any, and is there a canonical way to create tests? Are you open to people creating frameworks to do that? Would you like to share what you shared in voice?
Right, so in the tweet chat, I have posted a link to what testing currently is in Enso. It's a very simple testing framework, which is literally probably like 100 lines of code for the whole framework. It's very simple, but it does the job. And so yeah, so there is a way to test your code. However, for community contributions to that, I believe, and Wojciech, correct me if I'm wrong, that a testing framework is really something that is not that should not be created by the language. This is one of the things that is best offloaded to community maintainers. So in my opinion, if you want to create a testing framework for Enso that would be more fleshed out, that would actually be like a fully functional testing framework and not a very simple library, that would be great. And having like even passing the maintainership of the current testing framework onto the community, I think would be something that we could discuss further. I think we would be completely open to that, and it would be great to have a community maintained testing framework for Enso, and it's a huge amount of work, right?
Right. Yeah, for sure.
Okay.
I think this is we've spoken about community maintained libraries a couple of times on this stream, and in general, like, I mean, a couple of the a couple of the code bases that Marcin has produced live on this stream, we've like thrown up out into the ether for people to look after if they want to. And we had some interest in the shapes libraries, but in general, if like you're out there and you're thinking like, hey, there's something I want to make in Enso or for Enso, and you're interested in building that and owning it, but are scared about the long-term maintainership aspect of it, feel free to reach out and have a chat. Like, we're happy to talk to you about getting that started and what that could look like. But yeah, to dive into another question, because it's very relevant to something we did recently, Marcin. Excelexis asked, can you hook into the IDE visualization from Enso itself to, for example, implement your custom visualization and interactivity? Who wants to take this one?
Oh, that's all Wojciech. That's all his vision.
Go on, Wojciech.
Okay, so this is actually thanks for the question. This is a good question, and actually when we've been developing Enso, we were trying to do it in such a generic fashion that it just allows you to do everything you want. And this is what we've been tired in our lives earlier when we've been using visual programming languages in different domains. Like, for example, I was working in the visual effects industry. All the tools are pretty limited if you want to extend that. And we told ourselves the day first when working on it, so we don't want to do this mistake. So actually, yes, you can do it. So first of all, our visualization below nodes can be either chunk of JavaScript code or chunk of WebAssembly code. Regarding JavaScript, you can use any library there to visualize data. Regarding WebAssembly, you could also use any JavaScript library, but also there is a special library made by us. So we have created a very sophisticated shapes rendering engine that allows you to display like millions of shapes, 60 frames per second. And actually, our graphical interface is displayed with this engine. And for example, if you are creating library with this WebAssembly interface, you can use this engine and this WebGL engine to actually create a very, very performant visualization. And now, so this is the programming API. So what's in there? And now the question is how you can create the visualization. You can either write a code in JavaScript or Rust and compile it and just plug it into Enso. So just tell Enso, hey, here is the visualization on disk, and it will be loaded or on a server. Or you can create visualization from Enso. Actually, you can't yet, but we are working on that to allow you to do that. So, for example, there was a Twitch like 2 weeks ago or 4 weeks ago with Marcin and Joe, and they were showing how to, for example, how to connect paper.js into Enso. So on nodes, you can display shapes and tell how actually the shapes correlate to data. And then you could theoretically export that as a custom visualization. I'm telling theoretically because that was very, very early stage. So a lot more development would be needed to actually allow for creating custom visualizations by connecting nodes. But definitely we are working on that. So from the technical perspective, it is possible. Right now, there is not yet a library in Enso that allows you to create these very, very complex shapes, new definition of shapes directly on nodes. But yeah, that's definitely on our timeline. And also, we have everything under the hood ready for that. We just don't have enough manpower to actually bring that to life as soon as we want. So if anyone is interested, for example, to helping us doing that, we would love to welcome any contributors. We would hug them and tell them how to do it.
Awesome, thank you. Hi Martin, thanks for joining us all the way from Peru. So that, I think, is our backlog of questions. If anyone else has a question, please feel free to throw it into either chat, either YouTube or Twitch. We are watching them both. Sorry, Sylvia's just updating me on where we are with the new release. Perfect. So we have spoken about, all kinds of random library and like related topics about, what the vision for custom visualizations is, what the vision for data streaming is. I guess we haven't spoken all that much about the vision of the product itself. So right now, we've touched on this a little bit in some streams, that like Enso is both dual representation, so there's two syntaxes, and in some ways there's also like two, I don't know if this is the right word, but like execution environments, right? Where like the CLI works slightly different to the IDE. Can you tell us one of the common questions we've had from people who are like driving by the project and haven't necessarily been following Enso for a long time, has been like, what is the use case of this thing? Who actually would care about Enso? Why do I, as a programmer who's comfortable in a text-based language, care about visual Enso? Can you talk a little bit about that, Wojtek?
Yeah, definitely. So there are a few groups of people that could be interested in Enso from different perspectives. So let me start maybe not with developers, because this is when I will be talking about developers, I want to refer also to other groups. So let me start with actually, for example, business analysts. So business analysts are people who are right now, for example, using such software like Excel or Tableau. Sometimes they think SQL queries, and what they want to do is that they've got data gathered and they just want to extract from this data some business information to actually know how the company is performing, what the next business steps they want to take, etc. So Enso delivers for them a very interesting self-service business intelligence tool. So it allows them to like get into this data and query the data, visualize it instantly, and play with it. Ask questions and get instant replies without waiting for programmers or for developers to write scripts or bring that to them. So actually, for data analysts, we are providing a very interactive data querying tool. The next group, so the more technical group, are data scientists. So data scientists and data engineers. So they are programming on daily basis. They are writing sometimes R scripts, Python scripts. Regarding data engineers, they are also configuring, for example, Spark clusters. But let's stay on data scientists for a moment. And they actually also sometimes develop machine learning models. And the biggest value for them is that they can actually design the data workflows much faster than earlier, because after each step they see the results. Also, right now it's not in Enso 2.0, but we are right now adding it. On our nodes, we'll display sliders, checkbox, color choosers, and interactive widgets. So for example, if you load the machine learning model and you want to change its parameters, you would be able to just drag sliders directly on a node and see how this change affects this node and all other connected nodes interactively in the same time. And this has, for example, a huge benefit over notebooks, like, for example, Jupyter Notebook. The thing here is that, for example, in Jupyter Notebooks, the memory that you're working with is mutable. So whenever you change something, you need to rerun the next commands in order to get the proper results. Enso is immutable by default, and our compiler actually makes it fast, so you don't see it. However, when you change something, you can be sure that everything is up to date, everything is updated always for the data that you have provided. So first of all, you have a very great security regarding, when I get results, they are working on the data that I provided, they are not broken by some accidental mutable memory set earlier. And also, whenever you are putting something on a scene or changing anything, you immediately get results and you understand that much better than earlier. And regarding developers, so the group of people that are not, for example, working on daily basis with data science or data analytics, it depends on what you are doing. So if you are writing, for example, low-level stuff like some electronics controllers, IoT controllers, or binary serialization, custom formats for binary serialization, there's no point really in using visual environment. However, if you are processing a data that it's worth visualizing, it's worth seeing to understand, like processing graphics, processing sound, processing data for the needs of data science, or for example, connecting IoT devices, So you can see the current temperature, you can see the current level of voltage on some pins in your electronic devices. Then probably it would be much faster for you to just connect to these things and see live the output and just reconnect them together in a live environment. So what we are bringing here is really a live environment that allows you to play with data live. And what's more important, when you are done with playing, this actually should be a production environment without rewriting. You should just deploy Enso program to a server and be sure it's running fast, and it just serves you as a real environment, not only prototyping tool.
Awesome.
Joe, did I answer this question?
Yeah, I think you did. Yeah, for sure.
Okay.
And I was going to ambush you with the next. Oh, sorry, go on, Marcin.
I only have one remark about what Wojciech said, which I actually believed to be true for a long time, but I don't anymore. So Wojciech said something like, if you are creating a low-level serialization thingy, then you probably don't want to use Enso, and that's only half true. So since our IDE started working pretty well and I can trust it, actually when I'm doing something in the standard library, I use the IDE as essentially a REPL. So if I want to see like, oh, what would happen if I took this array of numbers and done thing X to them, it's actually a great environment to prototype even low-level things. Of course, you are not going to probably create. Well, I'm saying of course, but I'm currently not creating the production versions of the low-level things, but I'm prototyping them with the IDE anyway.
Awesome. Cool. So I do want to ambush you with something, Wojtek, because you mentioned Enso running on servers. We have vaguely, very loosely mentioned in the past the idea of like cloud services powered by Enso, or like cloud versions of Enso. Do you want to talk a little bit about, what
I would love
our
to.
cloud product might look like?
But before that, I would just answer one comment of GNX, XXX, and XLXs. So, guys, if you are interested in actually helping us, for example, deliver the testing framework or contributing in any way, don't worry that actually this is a foreign technology. I mean, we have team of like 12 developers working full-time on that, and they are super nice, super helpful. They are hanging out on Discord, and they would love to help with everything. And also, there are some tasks that are pretty easy to get into because the code base is already there. So it's not like writing something from scratch. It's just adding things on top of existing code base. Moreover, our build frameworks are also pretty nicely done. So for example, if you want to build the graphical interface after you install Rust on your system, you just run a script, run build, and everything is built and read and automatically served in the browser. So everything is automated and you don't need to like waste your time on configuring something. And we would love to help with any code questions, etc. So yeah, a lot of technologies that we're using were also new to us. So for example, before writing this visual interface, no one from our team was using Rust before. That's interesting. We were using different other languages, but never Rust. And yeah, we would love to help with that. So yeah, so going back to Joe, to your question. I forgot it. What was the question?
My question was, do you want to talk a little bit about like your vision for the cloud service and Enso, like the other Enso products beside the desktop ID?
Yeah. So we have that's actually very important. So that's very important. So we originate from open source community, and we love open source, and what we really want to do, one of the basis of our vision is that we really want to bring to people something that allows them to process the data and answer questions and get answers from data in a way that was previously not possible, in much more intuitive way. So we want to create the most intuitive data processing environment out there, and we want to give it for free to everyone. And I mean, our desktop version is free and will always be free. So we are dedicated for that, and also we have a very great luck that, for example, we are venture capital backed, but our investors agreed that with this vision that we should just give away the technology that we have created for free for everyone to use, and I'm super happy about that because we have amazing investors from all over the Europe, from Poland, from UK, from France. Anyway, so the first distribution is desktop distribution. You can download it, install it, use it for free, and it always will be free. We will have also two other distributions. The cloud distribution, so you will be able to just enter our website, click start, and run Enso in the browser. And we have also third distribution, which is on-premise installation distribution. And now there is a question of that naturally appears, how we, for example, what is our business model? And I believe that it's worth mentioning here because I also want to show that we are as open with, for example, being open source as possible. So regarding cloud version, we'll be charging for just normal usage of our cloud computing power, and we'll have there some additional features, but not regarding Enso, but regarding cloud, like automatic scalability or direct access to the data that is on your cloud. And regarding, for example, on-premise installation, we have additionally users management or groups management of users, so that someone is allowed to use some data, someone else not. But these are like server-like tools. Everything not connected to servers is open and will always be open and free. We also plan, from the business perspective, we also plan to create, and that's we are working right now on that right now. We want to create a marketplace, or even not. We can also tell that you can use the programming language here and tell that we are creating a repository. So marketplace doesn't mean that it contains only paid tools. In fact, vast majority or 100% of tools on the beginning will be free in this marketplace. So we want to give everyone possibility to just collapse few nodes together, create a library, and share with everyone else. But in the future, if actually we will be successful, then people definitely will start creating some libraries highly tailored for some domains like DNA, genome processing. And actually, some people already started doing that in Enso 1.0, and then they could sell these libraries through our marketplace. So this is from the business perspective. And yes, regarding the cloud version, this is one of the versions that we are working on, and we have a very, very early stage of that working right now. So we'll be exposing possibility of just running it without installation directly from our website, with the same functionality that you have on the desktop, plus automatic scalability and direct access to data that you have in the cloud without the need of downloading, which is of course why people want to choose this over the, for example, local distribution.
Awesome, thank you so much. So just a couple of reminders, keep those questions coming in. And on that note, God, I'm going to mess up this username. The Realm of Mechadence has asked kind of two questions, but I think we'll end up answering them both in the course of one, which is, would the graphical representation engine for Enso be adaptable to other languages that are quite similar to Enso? And I think an important reference for this topic, if you're interested, it would be to go back and watch the stream in our YouTube history. You can find it in the live streams playlist with Ara and Marcin about the introspection of Enso. But do you want to talk a little bit about, I think this is probably a question for you both, about how the visual syntax and the textual syntax interrelate and how the IDE actually works and builds on top of Enso as a language?
Right. So let me start from the maybe more backendy perspective on that. So there is the IDE, right? So like maybe certain blocks of the IDE could be reused. So this will be left to Wojciech, but I would like to talk about what makes this whole thing fly. And what makes it fly is, first of all, a very specific design of the language, so that we have immutable memory, we have pretty much that, and being purely functional, right? So we have no explicit control flow, so to speak. We mostly do value-based programming. So that makes things much faster to actually visualize, and then to let people to let the IDE do the things that it does, such as, for example, if you change something, if you change a single line of code, we'll only recompute a subset of your program, such that we do not waste time recomputing things that are guaranteed not to change. or even we can cache some values, right? So like if you're doing an expensive operation on a data frame, we will not be recomputing that. Okay, so that requires us to have full control over the execution of that program. That actually requires us to be able to plug into the interpreter or the compiled code, executing every single statement, and then add some additional logic on top of that, right? So what we do right now is the interpreter would execute line 1, line 2, line 3, but between the lines, we will read the value that was just executed. We will probably send a visualization to the IDE, add some profiling information, and so forth, and so on and so forth. I don't think this would be possible with any existing interpreter for any existing language. So if we wanted to do it, for example, with Haskell, I think this could be done. Like conceivably, you could represent Haskell as a data flow graph, but we would have to write our own distribution of Haskell just to let us do all of that. So that's the backend side of things. You really need full control over the execution of the program.
Yeah. I will answer that from two perspectives. First, from the graphical interface. So Marcin covered the backend. Marcin, do you want to add something, or you finished?
No, I was done.
Okay.
Waiting for you.
Okay, great. So regarding the interface, you can just split it over. So I mean that you can just take our graphical interface, our graph editor and everything, and you can connect it to any backend you want. You can use that for anything else than even programming languages. We have created it in such a way that actually our interface exposes a lot of input or interface, and this interface is using something that is called functional reactive programming interface, which means basically that whatever action you are doing in the interface, there is an event coming through some streams exposed, and actually you can plug into these streams and connect it to whatever you want. For example, our backend is plugging to the streams and connecting it to our language backend. So when you, for example, add a node, we are changing AST. When you connect nodes, we are doing that, etc., etc. But you can just disconnect these plugs and connect it to anything else. So yeah, you can reuse the visual interface any way you want, and also you can extend it. So, and we are very open for that. So this also would allow us to make the interface better in some way, even if it's not used only for Enso, but in different other products. So that's possible, and that's very cool. From the perspective of the language itself, we have designed Enso with this dual representation and graphical representation in mind. So, for example, I know Unison a little bit. So the question was about if, for example, we can use Unison in our node. So I know Unison a little bit. I know that, for example, they are not having really textual files. They are like keeping a database of every definition, and you can just load this definition, you can change them, and they are providing some interesting things about that, like, for example, very fast refactoring and accurate refactoring of every name. That's super cool. If I'm correct, they are also, I believe that the author of Unison, I was watching some lectures about that. He was coding that in Haskell, so I believe, or something like that. I'm not sure, but I believe that Unison also is purely functional. So actually, this purely functional language with immutable memory is like a basis for visual representation. Without immutable memory, graphs doesn't make sense. So you have two nodes. You want to know that node doesn't change its internal state without a new data coming through the line, and immutable memory is the basis for that. So if Unison is a basis on immutable memory, and also and all other aspects of the language are coded in such a way that it's suitable for displaying in visual environment, then definitely you can connect it. By all other aspects, I'm talking about a lot of stuff. For example, think about error handling in Enso. So we have a data flow errors, which means that when an error occurs on a graph, the error flows with the data, and even if the error occurs in some part of the program, other parts of the program still can continue evaluation. So errors are like iders in Haskell or results in Rust. So you're tagging a value with the error, and error automatically flows through the graph. We are also handling panics in a special way. So these are like important factors to consider. Also, for example, when you're thinking about this dual representation, there are a lot of things that normally we were not considering when starting the product. Like, for example, when you are editing the code, then during editing the code, you will be making syntax errors, right? So you will be after not the program after typing each letter is not correct. It's correct after typing few letters. So during typing, you will make errors, but you also want to update the graph. And for example, Enso works this way that even if you made syntax errors in the code, Enso compiler understands which parts are broken, which are not, and still allows the non-broken parts to be git compiled and run in the graphical interface. And every aspect of the language, including the monadic system, the error system, the algebraic data types, or how, for example, methods are defined and how type classes are defined. I mean, we don't have type classes, but we have the mechanism that is as powerful as type classes, but more stable for the visual environment. Everything this is designed for making this language visual first. So yes, you can connect other languages. The question is if the intuitivity and user experience would be as good as with highly tailored language, exactly for that purpose. Also, last thing is that we could definitely connect Unison as another backend next to Python, JavaScript, Java. So you could then use, for example, Unison codes inside of our nodes. But this is actually a longer and more technical thing because unlike Java, JavaScript, and for example, Python, Unison doesn't support GraalVM. So there would be a lot more to tackle there.
It's also, I think it's also worth noting that even though the IDE, like, you could think that it's a pretty general piece of software, right? Where you have expressions and you have nodes and you have connections and the connections go brr. But this is not actually enough for so our IDE actually ships its own parser for Enso that is written specifically such that Enso can understand that the IDE can understand what Enso is, what does it mean to make a connection, what does it mean to take a bunch of nodes and collapse them into a function, right? So the Enso IDE also is making a lot of assumptions about the underlying language. I guess this is kind of getting into the question that Exelixis was asking on YouTube. So technically you could swap out our backend and create your own for a different language. But this is my favorite kind of possible. So technically possible, but practically rather infeasible.
Yeah, so definitely you can just unconnect these all plugs and just take this visual environment and connect it to, I don't know, Flight Simulator. Oh, guys, I stopped hearing music and you.
Yeah, I think that was just a song ended suddenly. You're good.
So I didn't disconnect. Okay, that's great. So no, you can disconnect the backend and, for example, connect our nodes directly to your backend or to anything else like Flight Simulator or a game. But as Marcin told, we are focusing on making the Enso as user-friendly as possible. So I'm sure there are parts of, for example, design of the graph that are not as generic as you want them to be. But on the other hand, this is open source and you can extend that. So you can disconnect the backend and make our graphical interface more generic, and we'll be happy to always make these contributions. So we are as much as possible open for using every technology that we have here for other projects. Also, for example, we have distributed as a separate library, actually it is in the same repo, but it's a separate library, our rendering engine. So if you want to, for example, create either visualizations for another project or graphical interfaces that use WebGL under the hood and are so fast and so fluent as Enso interface, you can just use the library. It's exposed as a Rust library, so you have also to know Rust. But yeah, everything is open and as divided in components as possible.
Wonderful. Well, I think we got everything on that topic. There is Exodus did follow up with you could theoretically swap out the parser with mathematical expression parser and use it to write latex graphical
but
things.
there's better way of writing latex graphically. You can just create a library for Enso. So I mean that you can create like embedded domain syntax language and just create expressions that will So you can create on nodes expressions that when you connect nodes, they will under the hood create some kind of AST that will then under the hood pretty print to LaTeX. So this way we are connecting a lot of things. Like for example, we have database connections. When you're writing in Enso very nice expressions or connecting just nodes to select people by age, etc., and they are under the hood creating SQL queries and applying to database. So the same way you can do it. But yeah, if you want to go the hardcore way and disconnect the backend, I would love to see how it goes.
Wonderful. I do want to go back and answer one question very briefly, which was a question about like whether we, consider other languages competitors, and particularly that was related to Unison. I would think we've kind of demonstrated that we want to play nicely with everyone. We've really emphasized interop with other languages. I'm sure Marcin or Wojtek will correct me, but like I don't know, I think competition in the programming language space is a weird idea because different languages are good at different things, and people don't tend to just sit in one toolbox forever. So I don't think we particularly. The idea of programming languages competing is a weird one to me. I don't know if either of you disagree.
It's really one for me too. So every programming language is meant for something, and it's done with some purpose. Enso is meant for giving you this interactivity and giving you the most natural user experience when you're working with something that you can visualize and you want to get insights from. Or you can design something like music or graphics. Other languages are better in other tools, in other things. So, and that's why we also made Enso polyglot, because we believe that you would want to use other languages inside of our environment. If you will be writing some low-level controller for your smart house, you probably want to use C++ or Rust. Just write this component in Rust, put it in our node, and just then design the high-level infrastructure in the graph. So if you want to design how actually these devices connect with each other, how they speak the logic, use the visual interface because it makes sense. If you want to write some controller that needs to run on a very thin processor, then use C++ and then connect that into this environment. If you want to use some automatic parallelism that Unison provides, if I'm not mixing languages, then actually, write it in Unison and then connect it to our graph. So when you will be thinking about the whole process, then you can design it graphically. I don't consider any such technology as competitors.
I just want to add one thing, if you'll allow me to get all philosophical on you. If you look at the ecosystems of different languages, it's really annoying how they tend to specialize, and then you end up in a situation when you have the best data science toolkits in R and Python, and then you get the best like server-side toolkits in Java, right? Or you get the best, like the fastest prototyping framework for web apps is Ruby on Rails. You get that in Ruby. If you want to do anything beautiful, you probably want to use JS. All of those languages, all of them incompatible, which makes any decision about picking a tool for the job an absolute pain, right? Like, what if I want to create a web application that does data frame processing? Oh, oopsie! Now I have to like either use Django, which I really don't want to do, or I have to, I don't know, code my own data frames in Ruby. Not really feasible, right? So I think that the future is connecting all or at least the most popular languages in a single runtime, such that you can use the parts that are good in all languages and the bits of the enormous work that the communities of those languages have put into those languages. You can like, why not just share all of that in a single runtime?
I think this is not clear because I haven't seen it anywhere else than Enso, and I think that we need to emphasize that what Marcin just told. So guys, it is right now possible in Enso to write Enso function and write foreign Java import a Java library, and without writing any wrappers, you can call Java function from Enso. Then from Java you can even call JavaScript, and from JavaScript you can call Enso. And moreover, you can pass data between these languages. You can, for example, call a function from Enso, JavaScript function from Enso. In JavaScript, you can create an object and you can return the object to Enso. And Enso, without any wrappers, would understand that. We have a really fully polyglot system here. So you can really freely mix the languages. And what's very interesting is that there is close to zero runtime performance overhead. I'm talking close to zero because it actually exists, but it's getting smaller and smaller. So for example, right now when we are calling JavaScript functions, then JavaScript doesn't have threads under the hood. So always when you call a function, you need to check if a thread is running or what's happening with the thread. So there is small overhead when calling a function. But for example, there is no overhead when passing data because there is no data marshalling. All data between all the languages in Enso runtime, they are unified. And for example, regarding Python, right now we also are doing this thread checks in Python, but soon we'll be just utilizing the global interpreter log in Python, and then actually calling Python function would have zero runtime overhead. Calling Java function has right now zero runtime overhead, and passing any data, for example, to Java or from Java to Enso, has zero runtime overhead. So that's a true polyglot system that we are talking about.
We're Marcin and I are conspiring to show an example of this in the background from our stream last week. Our second stream was using Java Interop to write a HTTP server in Enso, and then we updated that last week with using the JS Interop to add server-side rendering via the EJS templating language. Marcin is pulling that up so we can show you an example of what Wojtek is talking about. Whilst Marcin pulls that up, we've spoken a little bit about community collaborations, and as someone who is on the contact@enso.org email alias, I know there is a lot of interest in people working more closely with Enso and, whether there are any roles and stuff here. You did recently post 2 roles on the team, Wojtek. Do you want to talk briefly about those roles that are open while Marcin pulls up this code?
Yeah. So we are always looking for people who can join us and help us develop the vision. We are always looking for contributors, but sometimes we are also looking for extending our team and just hire these people. And actually, some people from in our team started working with us as contributors, and then we told, oh God, it's so smooth, it's so amazing that we just hired them. So actually, I can think of Radek, Ara, and at least Radek and Ara were hired this way. So they started as contributors from our community, and we started working together. And we told ourselves, we just don't want to live without you guys. So and we are also right now hiring. So we are looking for someone who could help us develop this Enso cloud environment, and we are looking for like senior TypeScript and also senior Rust developers. So if you feel good at these technologies, please write to us on Discord, on mail, whatever, and we would love to chat about that. And and the location and time zone doesn't matter. I mean, we are located over the world, so we have people in Los Angeles, in London, in Germany, in Poland. Joe, where are you? You are in Amsterdam.
I'm in Amsterdam, yeah. As you can tell from the beautiful canal view.
Oh, yeah. I was sure that this is not live, I was sure that...
Oh, it is. I'm on a boat right now. I'm on the stream boat.
Oh, yeah, okay. Makes sense.
This is actually a canal very near me, though.
Yeah, makes sense. So it doesn't matter where you are, and doesn't matter what time you live, because we are also living in different times. Joe is always laughing at me because I'm an idol. I'm working in nights, so we are covering 24 hours, and so support. even if we were living in one place.
Yeah, Wojtek works the same hours as our guy in San Francisco. Oh, I can tell that Marcin has started up the IDE because I can hear the fans. Whilst doing that, in the chat, I have dropped this link to github.com/enso-org/hiring. That is where we put our job posts. That currently has the 2 roles, the senior Rust developer and the senior TypeScript developer. So if you are interested, that tells you everything about those roles and what you need to do to apply to them. Ooh, sorry, part of my desk just fell off. And if you have any questions about those roles or applying, again, you can jump in our Discord to... ask questions about that, which is there. And now let me throw up Marcin's screen. So we were talking about what interop in Enso looks like, and we were talking about that because we were talking about programming languages playing nice together. But we had this example from a stream a couple of weeks ago. I think that's big enough. If anyone in chat would like it bigger, please let us know, and we'll mash Control+. But I think it looks fine. So Marcin, what is happening on this screen?
Right, so this is exactly what Wojciech was saying about Java calling JS, calling Enso, calling JS, calling Java, in all different combinations that you can imagine. So
can you make it a bit bigger, please, Marcin?
Okay, sure. Is this big enough now? Okay, cool. Right. So this is you can see all of that in our GitHub. Someone will probably post a link in the chat. So this is a definition of a very simple HTTP server we have created 3 streams ago, I think, and that's all written in Enso but imported from Java. So you can see polyg.java import comsatnet HTTP server, and yeah, this class just appears in scope magically, and then I can do things like where do I actually use it? Wait, what is going on? Oh yeah, here, yeah, like I have HTTP server.create. So I'm calling methods that are in Java. I'm calling them directly. I'm even like using new. I'm actually calling Java constructors, creating new Java objects from Enso. So this is how you would wrap a Java library in Enso. Now, if you think about,
there's no wrapping. You can just import that. There is seriously no wrapping there.
Yeah, exactly. Also, if you think about an HTTP server is usually something that takes a callback, right? So we are importing something from Java. We are calling methods on it, and then we are passing callbacks that are written in Enso, so that Java HTTP server is actually then calling Enso again. And the callbacks that we are passing are the other cool thing about this whole tiny project, because they are written in JS. So you can see that I have ejs.js distribution here. So this is just downloaded from the internet. I'm calling it like I'm just loading it from JS. And then I'm calling it, and once again it will be difficult for me to show you where it's being called because it just looks like Enso. Yeah, like this call to ejs.render, that is just a call to something that's written in JS. You can't tell because it looks like Enso. So that's pretty cool. So we have imported an HTTP server from Java. We have passed it Enso callbacks. Those Enso callbacks are calling JS, but this is actually a templating library, so I have some JS code, EJS code, which compiles to JS. I have some EJS code that takes something that's called cookies and then goes to array and then calls JS methods on it, right? So I have an array, and as I would in JS, I just call for each on it, which is a JS method, and then I have an object called cookie. I call the method name on it, or like I get the value of the field called name. Now, where does that come from? And this is the surprise. The type cookie and the type bakery, which exposes the name cookies, those are defined in Enso, right? So we are in Java that called Enso as a callback, that then called JS, that rendered a template by calling back into Enso. This is the true beauty of polyglot programming, right? And also I'm currently working on Python, so we can probably make this monstrosity even more monstrous on one of the future streams when we actually add Python to it, because why not?
And yeah, Xelixis, I completely agree with you. So that's both pretty and ugly at the same time. But think about this way, that the whole thing. So what Marcin shows you now is that from Enso he is calling Java library, which is calling JavaScript, and JavaScript is calling methods that were defined in Enso, etc., etc. This just only shows the power of the system, that it's completely open, that you can really do everything there. But the whole idea, the beauty idea that still is beautiful in my mind, is that you can just create these graphs in our system, and you can just use any libraries from any languages, and you can, for example, just use Python to build TensorFlow models in a visual way, or then use Java to design some akka services in a visual way, without really trying to write wrappers, etc. So we never wanted to be in a problem of a new ecosystem where, yeah, there is a cool language, there is a cool system, but there are no libraries. We wanted to have all these libraries. And actually, this makes sense if you're thinking about this high-level visual data processing. You can just utilize anything you want, and we should take care of it working smoothly and performant, while you should be just free to use everything you want, no matter language under the hood, and just use languages that are more suitable for some things than other languages. So yeah, that's how it works.
And also all of that monstrosity that I just shown was created on stream last week and I think 4 weeks ago. So if you are interested in the history of how we started from an empty file to this spaghetti of languages calling each other, just watch our previous broadcasts.
Yeah, there'll be the previous streams disappear on Twitch after 2 weeks, but all of the history of our stream is up on YouTube. So if you go to youtube.com/Enso_org, you'll be able to watch them all. And also, an important thing to note about the fact that they happened on stream is that, that happened in no more than 4 hours because it was 2 streams. So you can really get quite far with a very little amount of time. And also, that was whilst Marcin was also thinking out loud and talking about everything he wrote. So I'm sure left to his own devices, he would have done that quicker even. So we are just past an hour. We have up to 2 hours marked out for this, so if you have questions, we still have time for you. So feel free to throw questions into either YouTube or Twitch. We're watching both channels. If there is no more questions, we'll just sit here and have a party and listen to my terrible royalty-free music, I guess.
No, actually, the music is amazing. But yeah. By the way, I will tell one more thing about things that are going on here. So also, guys, we have always conversations regarding, for example, the next libraries, the next areas that Enso should expose building libraries to, and this is always a very interesting topic for us. So if anyone of you want to share, for example, ideas that, I would love to use Enso in this environment, we would love to support that or help develop that or even develop that. And for example, we have a lot of requests right now to be able to develop graphics stuff in Enso. So for example, we have this forum on GitHub, and the most frequent request was about exactly developing some graphic things. So definitely we will be exposing a library, like building library to
just
create shapes.
Yeah,
to build shapes and to design graphics things. But basically, we believe that in the future we want to be the most intuitive way of processing domain data. We want to be applied in different domains, including IoT, pharmaceutics, discovering new drugs, processing data in banks, etc., etc. So if you came from one of these industries or any other industry that could actually utilize the power of this very intuitive visual way of data processing, we would love to not only chat with you, but also help develop some interesting libraries in these domains. So yeah, that's what I wanted to add here.
And up on the screen right now and in chat, you can find Enso-org Enso Discussions 1437. That is our library wish list. So if you want to share ideas for a library, or there's a library that you want to use Enso in your work or in your project, throw it in there. We are keeping track of all the requests in there. We do pay attention to them, and we do discuss them quite regularly in the Discord and on stream. And sometimes we build them. The Shapes library was like, and a teacher dropped into our Discord and was like, I want turtles in Enso, and then the next week we built it on stream. So come share your ideas, and on that note,
I haven't seen turtles in Enso.
Oh, sorry. Okay, it's an algebra of shapes to be accurate. I don't want to get told off. Next question, though. Thank you, Andre. And thank you, by the way, Excelis made the joke about their arms being tired of asking so many questions. Thank you, everyone who has asked questions. You've been amazing. There's been a whole heap of questions. It's been super fun to chat about them. And Andre has asked, are there any plans for being able to code Enso on the browser or on tablet and mobile?
No, there are no plans for that, because it's already possible. So yeah, we don't have plans for that because you can use it this way. I mean, our processing engine runs on JVM, so you have to have a server somewhere. You can run the server, for example, on your computer, but then the graphical interface is 100% WebGL, and you can run it on a tablet, you can run it in a web browser. In fact, the application that you are downloading is just a server and Electron application. The server is run, and in the Electron application, you can it automatically runs browser and connects to the server. And it connects via just a port on your computer, so you can expose the port and connect it via localhost, for example, from your tablet. I'm not sure that every shortcut would be working correctly on a tablet, but I was testing that once a few months ago, and it worked perfectly on my iPad. So we definitely have plans in the future to support it more, like put a big emphasis on being sure that iPads, for example, work 100% correct and everything. But yeah, it's already supported. Still, the data crunching engine works on JVM, so you have to run it on not in the browser and not on tablet until your tablet supports that. I don't think that there is a Graal distribution that actually allows that. But there is also one interesting thing, is that we are using Graal VM as our just-in-time compilation framework under the hood. And from what we know, the Oracle team is working right now. I mean, this will take them time, but they are working right now on compiling the things also to WebAssembly. So in some period of time, we would be also able to compile our compiler to WebAssembly and run it directly in the browser. It's not now, but it should be possible in the time span of realistically 2 to 4 years from now.
Just to add one more thing to that. So you said that it's possible to run it on an iPad, and that's true, as in you have done it, right? But we don't really have any instructions how to do that. We don't really. Do we support it officially? Like, can we actually like throw out some instruction of how to achieve that, or is it not supported currently? Like
we can. So it's not officially supported. It's definitely not officially supported. We can throw in up instruction how to do it. Actually, the instruction is pretty easy. If you download, for example, our distribution, you can, instead of just double clicking it and running it, you can just run it with flag -- no window. If you run it with -- no window, you will get in terminal information on what port and what address the IDE was exposed to, and then you can just connect to that via any browser, including, for example, your iPad. So that's pretty straightforward, but it's also not officially supported. I mean, there can be bugs. There will be bugs, definitely. So yeah, we want to support that. But basically, also, Andriy, if you have any cool use cases regarding how you want to use Enso on iPads, because actually we have heard about some use cases, and if we hear more and more about these use cases, we would just make that higher priority. So just tell us about those use cases. One of the use cases that I have heard earlier was about, for example, people working on in oil and gas industry, where they can actually go with tablets and being on a platform, not directly on a computers, they could, for example, analyze some data. So connect here and just process that. And that's super cool use case. If you have something similar, just tell us about that here on Discord. And then we are a small team, but we are trying to prioritize the things that are most popular. And yeah, this is something that is also very, very interesting for us. And answering the next question about the VR. So we never tested that in VR, but we are using, the interface is running in WebGL. we have a whole 3-dimensional scene there. So there are, what you are looking through is a camera. Nodes are planes that are grids that are in 3D space. When you are moving nodes, its 3-dimensional position is changing. The edges are also drawn using 3. Everything is in 3D, although it looks two-dimensional. So actually, it is pretty easy to connect to it web VR and just utilize it. There is one question about controlling the graph from the VR. So, for example, creating new nodes. In VR, you don't have this keyboard. You don't have keyboard, and I mean, you can you could have keyboard if you don't look at it, and you can type without watching. And of course, developers can do it, but not everyone. So there is a lot of questions regarding how to control graphs in the most natural way in VR. And to be honest with you, I would love to hear your thoughts about that. So if you can share, for example, your thoughts here on YouTube or on Twitch or on our Discord or on our GitHub issues or on our GitHub forum, anywhere. If you share your thoughts about how you would control the graphs in VR, I would love to participate in this discussion and just brainstorm about that. This is super interesting.
I have no idea how this should work, but I can imagine myself using it and feeling like in Minority Report going
yeah.
reordering nodes. That would be so cool.
That's what I was thinking when you were talking about VR. I have a Valve index. Give me a VR distribution. Let's go. I would like to try. I want what is that? Tilt brush? I want to be in the graph. I want the graph to be around me, like a painting in tilt brush. Be wonderful.
It should actually be like imagine watching a 3D plot in VR, right? Like you could walk into a part of your graph and then you like see all the data points around you.
Kira went to
another question.
Yeah, go for it.
We have another question that to be honest, I don't understand. I will try to read it, but I don't understand it. Is the Enso graphical representation off-road first class? That is, can the visual representation of the data in a node be Enso native graphical code representation? To be honest, I don't understand the question. Sorry, but I will try to answer that nevertheless. So, when you are coding graphs, when you are connecting nodes, we are generating textual representation. When you are changing textual representation, we are changing graphs. Our main representation is some kind of abstract syntax tree. And if you go inside a node, if you double click on node and you go inside, you see a graph, but you can switch it to text. You can then edit text, you can switch it to graph, you can edit graph. So this double representation is always switchable. So it's like no representation is more basic than the other. And they are fully interchangeable and you can use them. You can build, when you are building graphs, it's like coding. So for example, when you're collapsing nodes, then in the textual representation, we are refactoring the things to a new function, etc., etc. So I don't know if I answered the question.
Yeah, Realm, if that did or didn't answer the question, feel free to throw in some extra clarification and we'll try and answer. You did follow up with, can it be in the boxes? That makes me more confused. Sorry if we're struggling to get your meaning. Please let us know and we will try to expand. Excelis, that sounds super cool. Thank you for sharing. And I have no idea what Neo's VR game is. Karatata.
Yeah, I was just googling that.
Yeah, let me have a look, yeah. Cool.
Excelsis, you are talking that you are working on a generic interface for editing graphs and text using binary inputs. If I don't know how far along with that you are. But I believe that if you are still willing or able to, for example, switch technology, I would highly recommend, for example, using our interface framework for building that. I mean, our WebGL renderer, or even our interface, if you want, for example, to have node support there. So I would love to help you with that. I mean, well, we would love to see our both interface as well as our interface rendering engine used as much as possible in different projects, because this is amazing from both sides. First of all, we can help you build something that works amazingly fast and is very, very fluent. And on the other hand, we would have amazing contributions to also expanding the thing. So yeah.
Cool. Oh, well, we can still be here for a little bit longer if folks have any more questions. I just want to reiterate, this will be our last stream for a little bit. We're going to take a little bit of time off and work out what's coming up next, what kind of content we can do. If you have ideas about that, feel free to share them. What would you like to see? We have done live coding libraries. We've been on from both ends, from the IDE, from the visualizations in the IDE. We've done 2 Q&As now, one with Ara and Marcin about how the language is built, and now with Marcin and Wojtek about the future of the language and the vision and different things that we're looking forward to do in the future. What would you like to see? Would you like to see more live coding? Would you like to see something we haven't done at all yet? Let us know. We will be planning the next lot of shows from next week. and we want to make sure that we're doing stuff you want to watch, because otherwise, why are we here? So please feel free to share. Do you want
we are
hypergraphs?
also thinking. We are also thinking. No, actually, this about hypergraphs is explanation to the previous sentence. So Xelix is told that he's working on graphs on this generic interface for editing graphs, and the graphs have many versions, depending on I understand that a little bit, because in Enso we have also different versions of graphs. I mean, for example, when you want to profile your graphs, you don't want to show colors on edges. You want to show colors on the nodes that show you how fast the components are working, or where the slowdown comes from, etc. So we also have few versions of graphs, and this needs to be always very carefully designed. That's only you regarding the comment. And we have another question here. What abstraction do you choose? At the moment, I'm using that embeds all the above, but then every type of the graph editor needs to implement its own handlers. This is the second question that I don't really understand. I mean, what abstractions we are creating a graph representation that has different modes of display, and we are exposing that as functional reactive programming events to the outside world. So the outside world could just emit signal like switch to that mode, and then create a node, connect nodes, etc., and the graph will represent that. So, the graph has just different modes of displaying things. So you can, if you switch, for example, to benchmarking mode or profiling mode, then actually the signals are emitted through the graph and through your components. And for example, when you are switching to profiling mode, then nodes get the signal, hey, we are switching to profiling modes. We are disabling colors on edges. We are enabling colors on the nodes. And for example, when another event is going like, hey, the performance of this node ID was this, then it is redirected to the node, and node just says, oh, it's for me. I will display that with this color, etc. And when we switch back to normal working, the colors are dropped and the edges are highlighted again. So this is how we are handling that under the hood.
We also got a clarification from Realm about the question of displaying nodes in nodes. So I believe the question really is, can you display an IDE as a visualization in the IDE? Which I'm not sure. So we got a clarification of the previous question that you didn't understand. Well, none of us understood. So the question now becomes, can you display an IDE as the visualization of a node in the IDE? Which I'm not sure why would one want to do that. Like, why would you visualize
views of collapsed nodes? Maybe would be quite cool.
I mean,
but you can just preview your collapsed nodes just by going into them, right? And probably in the future, like displaying them in a smaller window. But this is
that could be
is
the smaller window, is what I'm saying. But yeah, sorry, go on, Wojciech.
Yeah, so definitely, right now, if you want to see what's inside the node, you double click on it and you go inside the node. We want to have a shortcut that would just like ghost the node, grow it, and you will see what's inside the node, and it collapses then back. But if your question is actually if you could run Enso and from Enso run another instance of Enso and just redirect the one graphical interface as a visualization to the first visual interface and display it as visualization under the node, then the answer is yes, you can theoretically do it. You can create such visualization, but I'm as surprised as Marcin why you want to do it.
Well, I mean, we back to Marcin's like technically possible versus
but also okay, no, like let's think about it. Let's think about it more deeply, because like they. So they say if code is being processed. So I'm thinking, like, for example, a macro system. So maybe that would actually be cool, right? So if you are writing a macro for Enso, you could create that macro in the IDE, and then like have it run on some test call of that macro, and then in the box you could see what the generated code from the macro would look like, something like this, right?
I'm not sure.
Code as data.
I love the idea, but I would rather not follow this as visualization. I would rather do that. If you are writing macro, you can see double click on the node and see like the expanded code inside the node, or just expand the node in place, like a normal function, but it will be just expanded macro. So yeah, that would make perfect sense. That's actually a very cool idea.
Awesome. Any more? Oh, Exodus said let's jump on a call sometime. Drop into our Discord, Exodus, and we can get that set up. That URL is discord.gg/Enso. And thank you all for sharing your projects as well. It's super cool to have a community of people who are interested enough in this area that you're also working on and building your own things. I think it makes
Joe.
Yeah.
What is the GG extension? Does it stand from Gadu Gadu?
No. Well, I don't know what Gadu Gadu means, but
I'm just joking. So actually,
cool.
to explain it to you and everyone not from Poland, actually, I don't know why, but for example, in Poland, there are technologies that are used instead of global standards. Like, for example, when everyone years ago were using ICQ, in Poland there was Gadu Gadu, which was a very, very popular communicator. Right now nobody uses that, but G is like a standard thing that is recognized for that.
Yeah, it's a good game, I believe. I don't know. I don't buy the TLDs.
It's probably a good game.
It's probably a good game. Yeah.
Right.
I now have to Google Gadu. Oh, okay, such a cute little logo. Sorry, marching on.
Yeah, so I have a question to Wojciech, which could be a solvable, could not be one. So we'll see. Like almost 2 years ago, we have started this whole rewrite of like, let's remove all of the HTML and make it and Haskell.
Sorry, Michael. Sorry, Marcin. I need to disconnect.
Yeah, no, okay.
I was afraid of your question. Yeah.
So we have started all of this rewrite, and I think we like explained multiple times to multiple people like why is this happening, what happened, and so on. And now it seems like we are emerging on the other side of the project. So we already have something that works after the rewrite, and it works pretty cool. So my question would be, how do you feel with that decision now? Like, how do you feel with Enso compared to Luna, and was it worth it?
How I feel with the decision. I'm not sure how I feel with the decision. I know how I feel with the outcome. I feel with the outcome amazing, and I'm looking at what we've got right now. I think for the first time in history, I can truly tell that I'm really proud at the product that I'm looking at. I never told that regarding Luna, so that's super cool. I'm really happy looking at what we've got right now. So of course this is in alpha stage, but what you did, for example, with the compiler, I told you that multiple times. You, Ara, and Dmitry, is mind blowing. I mean, the performance and the possibilities right now are something that I have never ever seen in another technology. Regarding the graphical interface, we never have any performance problems right now. So no matter the graph size, the rendering per frame is 3 milliseconds on my MacBook. I mean, the whole graphical interface, even if you have thousands of nodes with connections and with visualizations, is 3 milliseconds per frame if you're moving that. So there is 60 milliseconds is what you can utilize to keep this 60 frames per second. So we are utilizing only 3 milliseconds out of this thing. There is no garbage collection. The interface is never slowing down, and it's super, super amazing. So, and actually, the technology under the hood, from both sides, from the compiler and from the visual interface, is also mind-blowing to me. I mean, what we are doing, for example, in the visual interface, is that we have created a library where you define shapes in an algebraic way. You can, for example, define a circle, subtract another circle, add a rectangle, and then, for example, cut corners or all these shapes together. And every operation that I told, like subtracting shapes, adding them together, is almost free. I mean, it doesn't matter for us if you are subtracting 2 circles or you have 50,000 circles and another 50,000 circles and you are subtracting them. Subtracting will be as fast with both shapes. We did it because we did it this way, that when you are designing shapes, we are under the hood generating so-called sign distance fields. This is like mathematical representation of where the borders of the shapes are. Then we are compiling it to a very high efficient GLSL code. We are running that on WebGL. It gives us a very interesting mathematical anti-aliasing. So we are like like not using standard multi-pixel rendering anti-aliasing. We are just using a purely mathematical anti-aliasing in shaders. We have a very high quality of picture because of that. We have a very high performance of that, and basically what we've got right now is really something that I'm feeling proud of, and for the first time, and I see that it works amazingly. So yeah, I'm super amazed at that. Regarding the decision, Marcin, I would love to be at this point 2 years ago. You know that, you too, right? And when we were writing Luna, we may actually be doing the same that we did right now. Actually, we may, instead of making like hurrying up so fast and telling, yeah, we need to super fast hurry up to deliver the things in 3 months instead of 6 months, we could just take time and deliver the high quality production environment. We would then save a year. On the other hand, we would probably then not raise the money. We would probably not be in the place that we are in. So this is kind of a journey, but this journey has some downsides. So I don't like a lot of parts of this journey. Like, we should be at this point earlier. On the other hand, we would probably not be able if we not do this mid steps. I don't know if you feel similar to that, Marcin. I'm asking Marcin because he went through these downs and ups then when we were fundraising and everything. Next to me, we had some tough moments and some happy moments, and yeah, I shared with Marcin a lot of life on that.
Yeah, I honestly think this whole thing was a learning experience. So there was some vision, but there is also like you have to know how to do those things, right? I don't necessarily agree that we could have done all the things we've done earlier, because one, we didn't know that the solutions we've had were wrong. Yeah, like the problems didn't exist, so how can you solve the problems that you don't know exist? And also, some technology, like for example GraalVM that we use, that just didn't exist in a state stable enough to allow us to do that. So I don't know, like for me that was a learning experience, and I'm also very happy with what I'm seeing right now in the IDE. Another thing that I don't think we could have done differently is the complete rethinking of what the visual representation is, right? So in Luna, in Luna we've had this notion of a node that's a circle, and it has like some arcs on the left that are the nodes, and then it has some other arcs on the right, and we wanted to make it like beginner friendly. Like, we didn't want to scare people with code, but the actual result we've obtained was that this representation was not understandable to neither the coders nor the beginners, right?
What is interesting, actually, Marcin, you know that, but it's worth explaining right now in the middle of your sentence, is that most of visual languages use such representation that is not understandable by coders nor non-coders until you get into it. So we just followed a little bit the path that we knew back then, and then we discovered a new way of doing it.
Yeah. So this is, for example, a thing that I don't believe we could have come up with without doing it wrong first, and only then switching. So yeah, that would be my take on my own question.
Okay. Yeah. That's also a very good point.
Aside from Graal, I guess back then WebAssembly wouldn't have really been in a usable spot either. So I think there's technologies all up and down the stack that like wouldn't be usable that we're using now, right?
Yeah. The word had to become ready for Enso to exist, essentially.
Yeah. I mean, the old IDE was built on Atom, which I guess like it really tells you where things were then. That was before Atom was completely smashed by Visual Studio.
Oh yeah, actually utilizing Atom as text editor, we made two big mistakes. One makes me sad, and the other makes me terrified. The sad experience was with Atom. The terrified experience was with Haskell. So actually, yeah, I love Haskell. So Haskell is amazing language. It's one of the best languages ever created. I really love Haskell. The problem with Haskell is that we had a really good team of Haskellers, really good team, and I'm feeling also pretty good at Haskell. I was coding it for years, and the problem with Haskell is that performance is completely unpredictable. And this was one of the biggest problems that we had, that changing even one line, I mean refactoring of code, not even changing logic, but refactoring of code can break performance 100 folds. I mean, you can get instead of 1 second, your code starts running 2 minutes because you refactored the code, and actually the Haskell compiler didn't infer that in such code structure the thing could be unboxed and not kept lazy as func, but could be actually strictly evaluated. And also there is no tooling really that allows you to easily see that. So you can spend like days on tracking down what's happening there. And we gave up after a few such things with Haskell. Like, for example, we reported a lot of errors, like adding some context to a type definition made the program run 10 minutes instead of half a second. And the errors are still open. I mean, after like 5 years or 6 years of reporting, and really there are no it's not really clear what's happening under the hood. So we had really serious performance problems. Haskell is amazing if you are writing for example some processing code for end user, but if you want to write a compiler or a data crunching engine and you want to make it extendable, then this is not a good technology choice, unfortunately. Really unfortunately.
Awesome. That was a very cool line of questioning to go down. Do I have any other questions? People in chat, anything else? Just back to flat map. Yes, exactly. We've got about 10 more minutes, a little over 10 more minutes before we're jumping off. So there's any other questions you want to get on air? This is the time to do it. Would pick TypeScript over Haskell anytime. Interesting.
I mean, depending for what, regarding, if you are asking, for example, about the graphical interface, because we were also coding graphical interface in Luna in Haskell and compiling it to JS, then yeah, definitely TypeScript would be better choice. Right now we are using Rust instead of TypeScript. We are just compiling it to WASM, and Rust has two advantages over TypeScript. The first thing is that we don't have this garbage collector, which is important for rendering graphics real time. So we never have slowdown in graphical interface. You never have garbage collector. That's very important from our perspective. And the second thing is that we have this like type classes in Rust. So like imp, like traits that you can imp, and this is just a little bit better abstraction. At least for me, this is arguably better abstraction for keeping the code sanity than in TypeScript. But yeah, definitely TypeScript would be much better choice than Haskell back then regarding Luna. On the other hand, for example, regarding backend, right now we are using Java and Scala for our compiler and for GraalVM, and definitely GraalVM, this framework that allows us to utilize a JVM just-in-time compiler and all the goodies that JVM has, is incredible, and I would never replace that with for example TypeScript, because we would not achieve such amazing performance and such good JIT things, and also monitoring of things there, if that makes sense.
Someone asked, have you considered Go over Rust? And at this point I will mute before I have to shout generics at the top of my lungs.
Oh, come on, there is generics. There is this bash script that... So generics is a system where you have a, like in good languages at least, it's a system where you have a bash script that takes your code base and generates a bunch of copy of that code base with some type parameter.
And don't forget using the Greek Unicode angle brackets to implement the generic substitute syntax.
But I don't know if everyone knows why I ask about what generic is. There is amazing picture of of Go language and generics. I cannot find it, but if I find it in a moment, I will share that.
But anyway, yeah, I think also this discussion of Haskell versus TypeScript versus Go or whatever is kind of coming back to my previous point of you pick ecosystems and not languages, right? And optimally, you want to pick a language that is good at the thing that you are currently doing. And for me, this was a lesson learned the hard way with Haskell, right? Which is, I would say, probably one of the most elegant languages out there, or at least the most elegant language that could conceivably be used in production in 2016. And yet, it doesn't really help that much compared to like currently using Java, which is probably one of the least elegant languages out there. But it makes us much more productive and much more confident. Allows us to build a better product, even though it's a worse experience, I guess, on a purely intellectual level. Like writing Java doesn't spark joy like Haskell does, right? Like if I write a one-liner that is a function that takes 7 arguments, but I don't actually take any of those arguments, and I just like write a function composition pipeline, I feel smart, I feel like a genius. But what's the point of that if the code then doesn't work, or I don't know why it doesn't work?
Well, it only took us an hour and a half.
Got the image.
You got the image? How are you going to share this? Send it to me on Discord.
Okay, I'm sending that to you.
I'm glad it took us an hour and a half, but we finally got to the bit in the live stream where, surprise, people who write programming languages for a living have opinions about programming languages. We are. Okay, how am I going to get this image onto this live stream?
I don't know, but you should do it.
I mean,
okay, amazing.
Ara just posted it in chat. So.
Oh, perfect. Thanks, Sarah. Well, now that means
I
have to put the link. Hang on, I'll put the whole image on the live stream.
Display the image if you can.
I'm working on it. I'm working on it.
Yeah, amazing. So yeah, no, this is not this image. This is not the image that Ara posted.
Here we go.
Yeah.
Beautiful. Right over Wojciech's face.
Oh no.
I love this image. I really love this image.
Right. Yeah. And now we are getting questions about.
We're just really in deep now. Welcome to the programming language show, where we review the hottest new programming languages. We're talking GADTs. We're talking generics. We're on all the things. Oh, Ara wants to show that one. I'm on it, Ara. That one's very good. Also, now, apparently, you can just send me your programming language memes, and I will upload them into the stream. That's what we're doing now.
Meme hour with Joe.
This is how we get people to join our Discord. If you join our Discord, you can DM me your programming language memes, and I'll upload them right here into the stream.
Be careful, Joe, with the promises. I mean,
I feel like a bad radio DJ.
Creating multiple accounts for myself.
There we go, Ara.
Yeah. Excellencies, if you I would, if you allow me, I would not answer your sentence regarding generalized algebraic data types in Scala 3, because I really hate a lot of decisions in Scala, and I don't think this is good. I should maybe not go too deeply into that, but there are a lot of problems. I mean, of course, guts in Scala 3 are better than not having them, but still, the things that you are able to actually express there are so limited and so hard on the syntax in comparison, for example, to Haskell, and so limited that I don't understand why in the current reincarnation of Scala it is not designed in a better way. But yeah.
But also, it's worth noting, we have a lot of Scala code in our code base, and honestly, Scala suffers the same problems Haskell does to an extent, right?
Yes.
So it's compiling to the JVM bytecode, which is not really great for functional languages, and that means you sometimes don't know what will happen, right? It's trying to be this higher level of abstraction, and it is succeeding in a lot of use cases. But then when you are writing a compiler, you really want to be sure that like you want to be sure of the performance impacts of every single line of code, right? Because we are processing large data structures with really tight loops in different algorithms. You really don't want to have magic in there, and this is the great thing about Java, right? It's grossly inelegant in many respects, but at least when I write a line of Java code, I know what that line is going to do precisely in the bytecode.
Okay, we're not stooping to the level of just picking on poor JavaScript now. Poor JavaScript.
Joe, you promised something.
Yeah. Hey, no one has
Okay.
sent me any memes on Discord. I am. You sent it in Twitch chat, doesn't count.
You have to do it on Discord. Yeah, no worries. Yeah, here you go.
That is a good one as well, though. It's very good.
Yeah.
The little leotard. Cool. Let's Thank you, Excelis. I am driving engagement like a professional. So I think we have now that we're getting into the programming language wars, I think we've well and truly tapped out. So let's call it there and wrap up for the day. So just a reminder, this is our last stream. We will not be back next Tuesday. We will let you know when we will be back. It won't be too long. We'll let you know on the Twitter, on our Discord. That's Enso_org in most places. Enso-org on GitHub. If you have ideas for what you'd like to see, let us know in our Discord. Wojtek, any last words before we close out?
Yeah, one more question to people watching us right now. So I'm also thinking about doing some testing, like live coding, like when we are developing things. I will be developing, for example, the library management for Enso, so everyone can just click and share libraries, upload them, etc. And I just wanted to ask you, for example, what are your feelings, the people that are watching us? What are your feelings regarding live coding? Is this, for example, something interesting for you, or not? I'm just trying to get the answer over the next days to see if that actually makes sense. If that makes sense, we'll try to do it.
Yeah.
Well.
So to make that explicit, we've done some live coding on this show, building things with Enso. Would you watch building Enso itself? Would you be interested in watching the developers behind Enso work on Enso here on the stream? Yeah. If you would be interested in that, let us know in the comments, let us know on the Discord, let us know by carrier pigeon, however you prefer. And we'd love to hear from you as we put together the next lot of content. We have vaguely been talking about... So we had this kind of accident that happened where we said we were going to do office hours on Wednesdays, and we lined up a member from the IDE team and a member from the engine teams. It was meant to be 2 people. And then the entire company showed up. And that's now happened twice. And it's just kind of become a thing where we're like, maybe we should just do everything like in the open on Discord. So as well as talking about live coding, we've also been thinking about do we make more of our meetings public? We are an open source company. But of course, there's only point in us doing that if it would be useful or interesting to people. If you could not care less, that is also useful to know. So please let us know if you have zero interest in that.
I've got one question, Joe, to you. Enso is the future of data science.
Sure.
This stream is the future of Enso. So is this stream the future of data science?
Yes, unabashedly yes. I mean, it's still
thanks much for the action. Yeah, I know.
Yeah, I think the stream is coming to an end.
Yeah.
Yeah.
Well, this has been fun. Thank you both. And we will see you all in a couple of weeks. Thank you for tuning in.
It was
and
amazing.
again,
Thank you.
you can catch all of the recording of this one and all the past ones on our YouTube channel, which I still don't have a banner for, so I'm going to create that right now because I've complained about this 3 times now. Bear with me. It's youtube.com/enso_org. There we go. You can catch this recording and all the others right there. And we will see you next time. Thank you, everyone. Bye.
Thank you. Bye.
Cut him off midway. I always do that, my bad. Bye, everyone.